Let's talk about how we can find trig functions of any angle. So I'm not just talking about angles that are on the unit circle. This can be if I have a point and I want to find this angle, or if I'm given one trig function and I want to find others. These are the ratios that you would use. Sine of theta is still going to be your y value over r. And if you'll remember on the unit circle, our radius was always 1. So that's why sine of theta was always just y. But now we're going to change this and talk about trig functions where the radius wouldn't necessarily be 1. It's not on the unit circle. So we have to take into account the radius on these. So then cosine of theta would be x over r, and tangent theta would be y over x. It's still the opposite over the adjacent. And then the reciprocal identities, cosecant theta is going to be r over y, or just the reciprocal of sine. Secant theta is r over x, and cotangent theta is x over y. So we'll use these. You'll want to put those in your notes, and we'll use these to do a couple of examples. If you want to, I'm going to go ahead and pause and write the next example down on the paper. So here's the new problem. Let the point -3, 4 be a point on the terminal side of theta. So here's what this looks like. I've got an angle theta, and the point -3, 4, so up here, is on the terminal side of the angle. So the initial side would be here, and the terminal side of this angle is going to go through that point. So I'm talking about the angle that that looks like this. So that angle is actually going to have the same points as if I had a triangle drawn down to the x-axis. So I can find the sine, cosine, and tangent of this angle by drawing in a right triangle. And if I draw in a right triangle, I know that the length from here to here is 3 units, because this is -3, so that's 3 units, and from here to here is 4 units. So, I mean, we know that it's 3 units, even though this is the point -3, 4 right here. So, knowing what I know about Pythagorean theorem and the Pythagorean triplets, we know that this has to be a 3, 4, 5 triangle. And I could do that by doing 3 squared plus 4 squared equals c squared. So we know that that side is 5 units long. So if I want to find sine of theta is going to be the y value, which is 4, over the radius, which is 5. So sine of that particular angle is 4/5. Cosine of that angle is going to be the x value, which is actually -3, even though that's 3 units long, over the radius, which is 5. And then to find tangent, we're going to use our y value, which was 4, over our x value, which is -3. So the ratio of tangent for the angle theta is -4/3.